Hello and welcome to my little demo on a gear project I put together. Uh, Initially what you see before you is just a handful of simplified gears. Part of this project was to rather straightforwardly be able to convert angular momentum between gears without having to simulate actual physics with teeth and whatnot. There's a whole bunch of problems with it regarding collisions and with teeth slipping by each other. And so I was aiming to get around that by effectively having them translate angular momentum directly to each other as long as they're within appropriate ranges. So first we have this large gear on the right, which we can speed up, and we can slow down, and have it go in both directions. Each of these three columns just represents a location where we can set a gear. So we're going to start by running our system with this, and you'll notice that our smaller gears are in fact rotating 3 times for every rotation of our large gear here, and their ratio is 3 to 1. Math works out pretty simply there. When we add in a second column, the whole system will get moving in pretty short order. If we change this column, now there's only 2 gears. The rest of the system changes as needed for to maintain appropriate motion. So the right gear is moving clockwise, this gear here going clockwise, this one counterclockwise, making this gear move clockwise, and the rest follows suit afterwards. And so these gears make it a little bit messy to know the actual conversion. This gear is size of, I believe, scale 2, and this gear is scale 1.5. If you wish to do out the math, you could try and track things and make sure that everything's moving as should. But we go here, and we have 2 gears rotating again, and the whole system continues to move as intended. We can swap these gears around into this large sequence, and if we add this gear in, this one moves at speed with all the rest of them. You got to be careful when you're doing some of your angular momentum things, because depending on how you do your math, when you have a system like this ending gear could actually have a multiplied force, so you need to make sure that it all balances out in the end. Notice that both big gears moving at the same speed, more or less. There is one particular issue which is solved with a funny technique that I didn't come across until I was decidedly done with this. If we are to speed our system up real fast, which means that the angular velocity that all these gears are tracking is really high, and we hit the stop button, we get slippage. This is because of, since this gear is set to velocity 0 and the momentum is being calculated in collisions roughly equivalently between the gears, it'll take a few frames before the closest gears slow down and more frames for more distant gears to slow down. There are means of fixing this. Effectively, rather than calculating your momentum change between gears based on the actual velocity, you can actually establish points around the gear and have motion be determined and translated through that, causing all these gears to instantly stop because this thing has stopped providing new updated anchors to the other gears. And that's pretty much it. The only other real thing that you haven't seen is the last portion of column 2, but these all work interchangeably.